All right, hello everybody. We're going to go ahead and get started today. Today's lecture is going to be on solar and biomass energy. So we're going to look at the positives and negatives of these and fundamentally how they work. So the first one we're going to talk about is solar energy. So solar energy can be broken up into two main systems in which we generate energy from it. The first one is electricity generation, where we use photovoltaic cell systems or solar thermal systems. I'll talk more about that in a second. Or we can use solar energy for heat generations for heating different types of structures as well. So when it comes to electricity generations, the one that we typically see for private residential areas or small businesses, things like that, are going to be PV cell systems. So these are photovoltaic solar cells, and they're mostly be constructed of silicon and other conductors. So these are high tech machines, but essentially all they do is absorb solar radiation and then use the flow of electrons in order to generate electricity. Now, there are some positives and negatives that go with this. First, there's little to no direct emissions for pollution in either the air or noise pollution. They're easy to install. So you can see here, we can put them right on our roof. So we're not using up land or anything like that and having to destroy ecosystems in order to build these at a usable level. And each year they become more and more competitive in terms of costs because as technology gets better and more research is done in the area, solar cells become cheaper but also more efficient. Some of the negatives is obviously you're going to need access to the sun. If you have a cloudy day or if you're a place that has winters that are cold and don't get a lot of direct sunlight, well, that's going to heavily impact how much energy you're able to, um, create, which also means that you're probably going to need some sort of backup battery system to store excess electricity. And that also requires mining as well as other resources to be extracted as well. And then large solar farms. So if you have large areas of these PV cells, which are typically built in desert ecosystems, do impact some of those natural interactions that occur there. So here's kind of a breakdown of how these PV cells work. So we have the sun, it gives off solar radiation. Solar panels will absorb that solar radiation and be able to convert it to a DC current. You don't need to know all of those specifics about electricity, but essentially we then use an inverter to convert it to AC, which is a form of electricity that your house can use. So it can be sent to your house directly or sent to the electronic grid in total. Now, the other type of electricity generations for solars is more large scale. Essentially, what they do here is they create something called a solar tower, and the solar tower is going to have water flowing through it. And then what they do is they take something called heliostats, which are essentially just mirrors, and they redirect solar radiation in a large area around it and essentially hyper focus it on the water that is in the solar tower. This is going to heat up the water. The water steam is then used to spin a turbine in which electricity is generated, very similar to other types of electricity generation that we talked about before. So here's an example of a solar tower farm that we have here. As you can see, one of the main negatives that are going to go into this is going to be the amount of land it requires. You can see just the amount of solar radiation that is up here. But you're going to cause ecosystem fragmentation when you break up large areas in order to build these solar farms. Last type of solar system that we have to talk about is solar's solar energy used for heating, and this can be done either through passive or active. Essentially, the difference between these is one requires electricity, one does not, in order for it to occur. In a passive system, you're essentially just using large window panes in order for sunlight to access, and then that is going to be insulated into the house, causing an increase in heat. For those of you that have gone out to the greenhouse in the summertime, this would be an example of a passive system. There is no heat generated in the greenhouse from any type of electricity. Instead, we just simply rely on the large, clear plastic windows in order to let the sunlight in, not let it out. In an active system, what we're going to do is we're going to have something called a solar collector on the house. So that will collect sunlight or solar energy. And then a pump, which is run by electricity, is going to pump that water throughout the house that is heated up in the solar collector. And then that heated water will give off heat to the rest of the house. All right. The other type of electricity generation we're going to talk about today is biomass. And biomass is essentially just the burning. of living organisms in order to extract heat from it through combustion reactions typically. This is going to come in two forms. We're going to have our solid and our liquid, and we'll talk about both here today. So, the first thing I want to talk about when it comes to biomass is heavily used in developing nations due to its cheap cost. So, if you do not have an electric grid that's well established and well built, especially to rural areas, having biomass is something that each house could do individually in order to supply heat for cooking, but also for electricity generation as well. So, as I said before, biomass is often going to be used for cooking in developing nations, that you can see here. And there are some positives for this. It can be used for heating and cooking. It's relatively inexpensive and easily accessible. And a lot of times, this can be the only type of clean water that these people can get. So, they essentially burn or boil water in so they have nice, clean drinking water. But this is going to lead to a lot of negatives as well. This is a lot of particulate matter and other type of pollutants released by the indoor burning of biomass. Also, it's going to contribute to deforestation. So, in order to get this wood, it needs to be cut down from trees out in ecosystems. So, deforestation can be an issue if it is large scale enough. So, here's an example. Here's a rainforest in Brazil. And we can see that deforested areas, when it applies to either agriculture or indoor burning of biomass for electricity, can lead to a greater amount of ecosystem destruction over time. Now, to try to offset these deforestation and ecosystem impacts, a lot of times what nations will do is try commercial farming in order to grow biomass. And this can help reduce some of the biomass environmental impacts, like overall ecosystem destruction, besides the initial destruction to build this commercial farm. However, it does lead to other issues such as heavy nutrient uses. We talked about that in the agriculture unit in terms of using fertilizers in order to make these plants have higher crop yields. Also, you're decreasing biodiversity due to monoculturalism. And if you're planting any type of plant that is not native to your area in order to get a more higher efficient biomass, this could lead to more invasive species over time. Now, when we look at large scale biomass burning, like we see in this power plant here, there are some negatives that go along with biomass, including the number of air pollutants that are released, such as carbon monoxide, nitrogen oxides, and VOCs. Now, we'll talk more about these air pollutants when we get to Unit 7, but all of these contribute to smog and other types of air pollutants that have negative impacts not only for ecosystems, but also for human health as well. Now, biomass can also include liquid forms as well, not just solid forms. You probably have seen this before if you've ever seen E85 at a gas station. That's ethanol 85, and essentially that is built up of corn product, and that corn product can be used to kind of offset the amount of fossil fuels we have to use. And what's nice about the liquid form of ethanol is it does reduce foreign dependence. So if you are a nation that doesn't have fossil fuels naturally in your borders, you can use corn to try to offset how much fossil fuels you have to bring in. Plus, it's carbon neutral. Any type of carbon that is released through the burning of corn had to have come in there through photosynthesis. So the amount of carbon in and out is going to be neutral. And then also, these liquid biomasses use current infrastructure. Right now, our infrastructure is set up for gasoline, and so anything that is liquid and can naturally use that same system is definitely going to be supported economically over things like an electric grid used for EVs that have to set up a whole entire new system in order to get to run efficiently. Now, some of the negatives of liquid ethanol or liquid biomass is that it has low net energy and it requires large scale agriculture. So go back to that unit 5 to better understand some of those agricultural impacts that comes from large scale agriculture. Now, like I said before, typically what we do is we mix this ethanol with other types of gasolines or fossil fuels that already exist in order to make a mixture. So, like E15 would be 15% ethanol, or E85 would be 85%. Now, corn is the example that I used over here. However, there are a lot of different plants that it could be mixed with when forming the ethanol. Things like corn, sugarcane, sugar beets, or soybeans would just be a few examples. Now, biomass is still kind of in its early days in terms of trying to make it more relevant and economically viable. However, there are a lot of startups today that are looking to make biofuels more and more available, especially for developing nations. For example, switchgrass is something that's being researched right now as an alternative for certain fuel types because it grows very easily. It's a natural species in a lot of grasslands and can help decrease foreign dependence and is carbon neutral. Algae is another type that's being explored for energy sources as well. So, biofuels, while probably will never be the predominant type of energy source of the future, it is efficient at covering very niche needs, especially in developing nations. All right, so that's going to be it for today. There is an FRQ here. Please make sure you answer this, and we will go over it on Monday.